All right, so today is the third topic of our function class, and we're going to talk about quadratic functions, definition, graph, and main properties, then quadratic equation and inequalities, and last, linear quadratic systems. Okay, as usual, first we'll have a look at the definition of quadratic function. Quadratic function has the form y equals ax squared plus bx plus c, where a is not 0. The highest order of this function is 2. Compared to linear function, we have increased the highest order by 1. So the highest order is 2. In this case, it's called a quadratic function. For example, all of these functions are called quadratic functions. You clear with the concept? Yes, I'm clear. Okay. All right, so are you familiar with the graphs of quadratic functions? So usually, when we learn a new function, we'll have a look at its graphs and together with its main properties, right? So are you able to, let's have a look at some examples. Are you able to draw the graph of these functions? So actually, the first parameter is related to the direction of opening. As you can see here, all of the four functions have positive leading coefficient, and all of them opens upwards, right? You follow me? Yeah. If you change the leading coefficient as a negative number, all of these curves will be going down, will be opening down. Okay, so let's make a summary here. A quadratic function has the form y equals ax squared plus bx plus c, where a is not 0. The graph is a parabola with the following properties. It's concave up if a is greater than 0, which has this shape here, and concave down if a is less than 0, which has the shape here, like this. And have you learned axis of symmetry? It's actually also symmetrical about this line, right? And this line has this equation, x equals negative b over 2a. And also, that's also the x coordinate of the vertex here, negative b over 2a. How about this y coordinate? Yeah, you just insert this point to the equation, right? And it's always, well, if you understand the problem, it's always better to memorize this. The y coordinate is this expression. Okay, that's the coordinate of the vertex. Okay, I'll just pass this then. Okay, and discriminant, you know this, right? B squared minus 4ac. That determines what type of roots you have. Yeah, you have, in that case, you have two different real roots, right? If delta equals 0, you have two identical real roots. If delta is less than 0, no real roots. But we can solve the equation in complex number domain, right? Are you clear? Are you clear? Okay. And also note that the width and strength width and stretch of this function is dependent on a. Larger absolute value of a means narrower parabola. Y-intercept occurs at 0, c. Well, in order to find its x-intercept, you simply solve the quadratic equation. You let y equals 0 to find all the x-intercepts, right? There could be either 0, 1, or 2 x-intercepts, right? Are you clear? Okay, I'll just pass this. And there are three forms of equations we can use for quadratic function. Okay, so I'll just pass this. Make sure you convert between each one of them. So let's see an example here. Are you able to solve this question? If yes, I'll just pass this, okay? Well, if you know how to solve it, I'll just pass this because we don't have enough time for this. Okay? Okay. If you're confident in this, I'll just pass, okay? How about this one? Yeah, you can show your work on this. Yeah, that's why we give it a brief review here. You can select each one of these three equations to represent a parabola or quadratic function, right? Just make sure you use the correct use a proper one to simplify your problem. Well, if you know the coordinates of a vertex, it's better to use a vertex form, right? Okay, so you want me to show it? Okay. All right, let me know if you finish or if you stuck anywhere, okay? There is no slope for a parabola. Slope is a concept of line, right? Yes, A is called leading coefficient or stretch factor. Yes, because there is unknown value A, right? So at least you need one equation to solve that. Yes. So because if the question tells you the vertex, then we can simply let the desired function be use a vertex form, right? Y equals a x minus 1 squared plus 2. X coordinate, y coordinate of the vertex, right? Make use of the information given to you. And then insert 3, 3 to that equation to solve for the unknown value a. Then you will get the final equation. Yeah, that's correct. Y equals a quarter times x minus 1 to the second plus 2. Okay, let's see another one. So how about this? So this time, it only gives you 3 points on the problem. No vertex. How do you solve this? How do you find the equation of the quadratic function? So note that you have 3 options to choose from, right? If you know the vertex, it's better to use the vertex form. If you know the 2 roots, it's better to use the factored form, right? Factored form? Why is possible? You don't know the roots. You don't know the roots here, right? In order to use the factor form, you have to know the roots. If you don't know anything about it, it's it's better to use a general form, right? So make sure you're able to you are very familiar with these 3 forms and choose one of them according to the specific question. Okay, sometimes vertex form is easier, sometimes factor form is easier. If you don't know anything, you can just always refer to the general form, right? Yeah, because first of all, we don't know the vertex, so you can't use the vertex form, right? Second, you don't know the zeros, so you can't use the factored form, right? So make sure you memorize this slide here. So first understand them and then memorize all the contents here, okay? So memorization is based on understanding. Understand first and then memorize, okay? All right, so in that case, the factored form involves 2 parameters, P and Q. P and Q are the zeros of the quadratic function. Can you see that? You can only use this form when you know the zeros, right? For example, if I give you a graph here, you know this point is -2 and this point is 3. Then we can write this function as y equals a times x minus 2, which is x plus 2 times x minus 3, right? So let's get back to this question. In this question, we don't know anything about the vertex or the zeros, right? So the only choice is to use the general form. We can let y equals ax squared plus bx plus c be the desired function, right? Then you need to solve a, b, and c to get the desired function. So there are 3 unknown values, right? So according to the basic principle of algebra, you need at least 3 equations, right? And luckily, there are 3 equations because you can simply use these 3 points. For example, the first point is here. It's on the curve, which means it will satisfy this equation. So we can just insert this point to that equation, right? This will give you -5 equals 16a minus 4b plus c. So same thing for second and third point. Just insert the coordinates of that point into that equation. Because that point is on that curve, so it must satisfy the equation. So the second one gives you 4 equals a minus b plus c, right? And the third one is -20 equals a plus b plus c. Well, usually it's better to write the y on the right side. So that equals -5, 4, and -20. And the next question is, are you able to solve a system involves 3 linear equations? Are you able to do that? Well, if you have two equations only, uh, what is the nature behind this question? If you have, for example, two of them, uh, well, I'll just write a arbitrary one, so something like this. Let's say 24 equals 1. So how do you solve an equation like this? Yes, the nature behind this question is to reduce the right? Because if you end up like 2a equals 13, it's very simple because we only have one variable. We have already know how to solve it. So if you have two equations, then just try to reduce the unknown quantities. So same thing for a system of three linear equations. First, you can reduce the number of unknown quantities from three to two, right? So we can use equation number three minus equation number two. This will give you 2b equals negative 24. And actually, we can direct solve b, which is negative 12. Then let's call this number 4. Then we can number 1, which will give you 16a plus 48 plus c equals negative 5. Simplify to 16a plus c equals negative 53. And then insert equation number 4 to 2. And this will give you a plus 12 plus c, which equals 4, right? Simplify to a plus c equals negative 8. And then let's call these two equations number 5 and number 6. Then you can further eliminate the number of unknown quantities. For example, you could use equation number 5 subtracted by equation number 6. And this will eliminate c, right? This will give you 15a equals negative 45. Then you can solve a equal call this equation number 7. Then insert equation number 7 back into 6. And this will give you negative 3 plus c equals negative 8, which means c equals negative 5, right? And therefore, you have solved a, b, and c. Then we know the equation of that quadratic function. So the because we could say the desired function is y equals negative 3x squared minus 12x then minus 5, right? You follow me? Okay. And next quadratic equation. Okay, let's see. Simple. So if you have a quadratic expression or quadratic function, simply let this function equal 0, then you will have a quadratic equation, right? Of course, the leading coefficient a cannot be 0. Otherwise, you don't have this term. That's actually linear, not quadratic, right? And common methods we can use to solve the equation are factorization, completing the square, or just directly use a quadratic formula, right? I think we'll just leave this section to our next class because it involves a lot of trivial things here. Uh, how about the Vita for Vita's formula? How about this one? Are you familiar? Well, sorry. I lost my speaker. I need to switch my speaker. Yeah, can you repeat? Oh, actually, that gives you the relation between the roots of a quadratic equation and its coefficient. Okay, can you prove this by yourself? Yeah, can you try? Let me know if you finished or if you're stuck anywhere. Okay. It gives you the relationship between the roots and coefficient. It says if x1 and x2 are the roots of the quadratic equation, then the sum of the two roots equals negative b over a, and the product of the two roots equals c over a. All right. Let me know if you finish or if you're stuck anywhere. We need a formal proof. I can explain. I can try to explain. Yeah. So you have to like find the roots first. So maybe like put it into the factored form first. Like a like the factored form is a bracket x minus r1 times x minus r2 equals 0, right? And then you expand it. So then I got x squared minus r1 plus r2 times x plus r1 times r2. And then what did I do after that? Yeah, that's all I got. Okay, well, wait. I think no. Just expand it, like expand the factored form and compare it with the general form, and I think that proves it. Yeah, that I'll do. Well, you can also do this. If you have a function like this, right? If you can somewhat solve x1 and x2, then you can always check what is the sum of the two roots and what is the product of two roots. And luckily, the quadratic formula gives us a way to solve this equation, right? Yeah. So if x1 is this is one of the two roots, right? Whether it's real or not. And then the other root is this one. Oh yeah. So it's very simple, right? For quadratic equation, we can use this method. So x1 plus x2 is simply negative b over a, right? then x1 times x2, you can verify this by yourself. Rationalize the numerator will give you c over a. Can you see that? So this is called Vita's formula.
Oh, wait,
for
yeah.
quadratic equation.
Yeah, that makes sense because you can cancel the terms, and that's what.
Yes, it can also expand it to a more general case. It's also true for polynomial equations, and we'll talk about polynomial functions equations at a later time. So currently, as long as you know the Vita formula for quadratic equations, that'll be fine.
Okay. Yeah.
Okay. And next, let's have a look at some examples. Can you solve this equation? This is a quadratic equation, right?
Yeah.
Are you able to find a quicker way to solve it?
I mean, I usually use factoring, so I'll try that. If it doesn't work, I'll just plug it into the quadratic equation. Or is there like, I know there's like a completing the square method.
Yes, completing the square is quicker than just factoring it, right?
Yeah, I just forgot how to do it, but I'm pretty sure it works for this one. I think it's x squared minus 2x equals 9, and then you do negative 2 divided by 2 squared.
Yes, so usually you analyze the term in the middle. If you have a negative 2 here, then you can write this as x minus 1 squared, right? Because we know a plus b squared equals a squared plus 2ab plus b squared. Are you familiar with this formula?
Yeah.
This is some basic algebra manipulations, right? So if you expand it, you will get x squared minus 2x plus 1 here. We only want the first two terms, right? You don't have a plus 1 here, so compensate this by add a negative 1. So this will give you exactly x squared minus 2x, right?
Yeah.
Then copy the rest of the expression. This is exactly the same with the previous equation, right? And this is equivalent to x minus 1 squared equals 10,000. And we know x minus 1 is either plus or negative 100. So x equals negative 99 or 101, right? Of course, you can also try to factorize that, but it's not very easy to factorize this. Okay, let's see another example. Can you solve this equation?
Yeah. Can I just annotate this? Can you factor this? No.
Yeah, can I interrupt? Yeah, this example, I want to use this example to illustrate that it's not always for you to factorize a quadratic expression, right? If you cannot factorize it easily, you can always refer to the quadratic formula.
Yeah, I can do the quadratic formula.
Okay, so I'll just pass this, okay?
Okay.
And okay, let's see the last example to wrap up this lesson. How about this question here? Suppose x and x1 and x2 are the roots of the equation. Here, what is the value of x1 squared plus x2 squared? Any thoughts?
I'm not sure if I can use the formula for this.
Okay, I'll give you a hint. If you have a plus b squared, then explain it will give you.
So you want to use a completing square method?
Yeah, does it ring any bell? So in this way, you can write.
I get it. So x plus 2 squared.
Yeah, and then
x plus 2 squared is that?
how about compensate by add a negative 2x1 x2. Then this will be the exact same with the left side, right?
Yeah.
Are you able to find x1 plus x2?
Yeah.
What it is?
X minus negative b over a.
With theorem, right?
Yeah.
How
So
about
like
x1 times x2?
That's c over a.
Yeah, can you give it a try? What is x1 squared plus x2 squared?
Let me just try to solve it. X1 squared plus x2 squared. So x1 plus x2 equals negative 3 over 2 squared. No. Is it 9 over 4?
9 over 4 is x1 plus x2 squared, right?
Yeah. But I didn't do the other half, sorry. I should continue on. I'm not done yet.
Okay, that's 9 over 4 minus 2 by negative 2, right?
Yeah.
That's 24 over 4.
Yeah, one sec. Let me just complete it.
That is x1 squared plus x2 squared.
25 over 4?
Yes.
Yeah.
Alright, next let's have a look at quadratic inequality. Okay, if you have a quadratic function and on the right side, if you add greater than or equal to 0 or sometimes strictly greater than 0, where a is not 0, then you will end up like a quadratic inequality. Okay, let's say an example. Can you solve the inequality 2x squared plus 11x less than 21? Which means you need to find an interval of x such that 2x squared plus 11x is less than 21, right? Are you able to find such a interval to make this happen?
I think I can solve this. It shouldn't be too. I think it's like the same as linear one. You just use the equal sign first, and then at the end you convert it back.
Yeah, can you give it a try?
Okay. Okay. So 2x squared plus 11x minus 21 is equal to 0. Okay. So m equals 14, n equals negative 11, negative 3, and 2x squared plus 14x minus 3x minus 21 equals 0. 2x x plus 7 minus 3 plus 7 equals 0. 2x x minus 3 equals 7. Do you want me to graph it or just like solve it?
Solve it.
Solve it.
The question only asks you to solve the inequality, right?
Yeah. x is smaller than -7.
Smaller than -7?
Oh,
okay.
Wait, no. No. X, can I think this is it. I'm not 100% sure.
Okay, let me give you a hint. If you know the graph of the function, it could be very easy to find any interval such that the function is smaller than 0 or larger than 0, right? You could use the graph of this function to help you to find the correct intervals.
Is this the right interval?
Between -7 and 3/2. That's correct.
Yeah, that's what I got.
Okay. Actually, you can do this. So put everything on one side, right? Because this does not affect our final solution. Put everything on the left side. Then we can factorize the left side in order to find if there are some zeros, right? So if you factorize that, you will have x plus 7 times 2x minus 3 less than 0. This is not hard because we can just use a cross product method. X, then you will have 2x. X by 2x will give you 2x squared. Then you have -21, which can be factorized to 7 by -3. Then cross product will give you 14x minus 3x equals 11x, which is a term in the middle here, right? So x plus 7 is our first factor, 2x minus 3 is our second factor. So first of all, let's sketch the graph of this function. Leading coefficient is greater than 0, right? So it opens up, right? And then it has two zeros. One of them is -7. The other one is 3/2, right?
Yeah.
We don't care about the position of y-axis because it has nothing to do with our solution to this inequality. So this question really asks you to find the interval of x such that the function is less than 0, which means under the x-axis. So apparently that is between -7 and positive 3/2.
Yeah.
Excluding the endpoints, right? So we'll circle the endpoints to exclude them. And therefore we can conclude x is larger than -7, smaller than 3/2. Is this quicker?
Yeah.
Okay, so let's see another one, similar one. Can you solve this inequality in the real number set? Okay, I'll give you a hint. There are only 6 possibilities of the graph of a quadratic function, right? Opens up, no x-intercept, opens up, one intercept only, opens up, two x-intercepts, or opening down, no intercept, opening down, one x-intercept, and opens down, two different x-intercepts, right?
Yeah. Is it okay if you go back one slide for a sec? I just want to write down.
Yeah, you could use this symbol to denote this transformation is equivalent to the previous one. Equivalent means they have the same solution.
Yeah. Yeah, got it. This one will be. x is smaller than -6?
Can you double check? Okay, can you sketch this graph? Which one is?
Oh wait, never mind. Wait, let me.
Which one is a correct sketch of this graph?
F.
F?
E or F?
Does it have two roots? Two real roots?
No, it's E. Sorry.
E, right? This one, right?
Yeah.
Because we can consider the function, or you can simply factorize the left side. So if you call this star, then first, well, for me, I don't like negative leading coefficients, so we can multiply both -1 to both sides. So this is equivalent to x squared minus 12x, then plus 36, less than 0, right?
Yeah.
So basically we want to solve this, and this can be factorized to x minus 6 squared less than 0. So leading coefficient, if you consider this function, leading coefficient is positive, so it's opening up, and then there is 1, 0. So if you consider this function and not this one, this function, then it will only touch x-axis once at x equals 6, right?
Yeah.
Can you find any x such that this function is less than 0? No, we can't find that, right? So there is no solution in the real number set. Can you see that? Well, actually, you can also end here. You don't have to draw this because we know any real number squared cannot be less than 0. So no solution in the real number set, right?
Yeah.
Either way, so a generic way is to always use the graph to help you find any interval such that the function is less than 0 or greater than 0, right?
Yeah.
Again, make sure you are very familiar with the graph of a quadratic function. It's very helpful when you are trying to solve an inequality. Okay, let me know if you finish, okay?
Yeah.
Let's see another example which really checks your understanding of the connection between the graph and the expression of a quadratic function. K is some real constant. For what values of k the inequality here has the solution x can be any real number. X belongs to the real number set. Which also means for any x belongs to the real number set, the inequality is always true, right?
Yeah.
So what is k?
Is k equal to 3?
Okay, can you show your work on the screen? How do you get that number? Should be greater than, right? x squared plus x. Okay, from this step to this step, how do you get there?
Oh, I just use the random value k.
Okay, x squared plus k over 3x is greater than -3, right? Then how do you get x squared plus x is greater than -3? Okay, let's, can you erase this? Let's rethink this question.
Okay.
Again, we can always make use of his graph to help us answer this question. So let's consider this. Let's consider the function here. Put everything on the left side. Then let's consider the corresponding quadratic function. Y equals -3 x squared minus kx minus 9. Okay, first of all, this is a quadratic function, right?
Yeah.
Does it open up or down?
It goes like this.
Opening down, right?
Yeah.
There are 3 possibilities, right?
Yes.
It could have 2 zeros, or it could have only 1 zero, or it could have no zeros. These are the only 3 possibilities, right?
Yeah.
So which one do you think is correct, such that the function, no matter what x is, as long as x is a real number, this function is always less than 0?
C.
So it must have a graph shown in C. Only in this case, no matter what x is, as long as x is a real number, the whole function is less than 0, right?
Yes.
So how do you ensure C is true?
By making sure the vertex isn't.
So we need to ensure no zeros, right?
Yeah.
So
discriminant has to be less than.
Yes, no zeros means, or equivalent to delta must be less than 0. So as long as you make delta less than 0, then this will be true, right?
So 0 is less than 4ac. No, b squared minus 4ac.
So what is delta here? Delta is k squared minus 4 by -3, right? By -9. You need to make sure this expression is less than 0, right?
Yeah.
Which means k squared must be less than 108. Can you solve k?
K squared is less than 1. K is plus minus square root of 108.
It's not a single value, but an interval, right?
Plus minus square root of 108.
Yeah, so k is between negative square root of 108 less than positive square root of 108, right?
Yeah, which is around like 10.1.
Yeah, simplify to k must be between -6 square root 3 and +6 square root 3, right?